Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com program, brought to you by Techstrong and SciCode. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we do have an exciting presentation ahead. First, I have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, or maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab, which can be found on the right side of the screen. On the right side of your screen is where you'll also find the chat tab. This chat tab is where we want you to get to know your fellow audience members. Let us know your thoughts throughout today's program, or maybe just from where you are joining us. We do have a couple of handouts available for you under the handouts tab, so feel free to check those out at your own leisure. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of today's program. So on to our topic, doing more with less, how to improve AppSec programs when budgets decrease. I'm joined today by John Jarbo, Director of Product Marketing at SciCode, and Orion Cassetto, Head of Product Marketing at SciCode. So Orion, John, thank you both so much for joining me. I'm going to let you get right to it. John, do you want to take it from here?
Oh, sure. Thanks, Cody. So hi, everyone. As Cody said, I'm John Jarbo. I'm Director of Product Marketing here at SciCode, and I've been in the cybersecurity space for about 15 years. A lot of my experience has been in the AppSec space. I've been at a number of different AppSec companies with Coverity and Checkmarks and Contrast Security. I've also been in kind of the broader cybersecurity space, companies like Tenable. My background is more on the technical side. I started as a developer. I have a computer science degree. I've done everything from development to pre-sale engineering, post-sale engineering, consulting, all of that stuff, and I have a very well-rounded view of kind of what cybersecurity looks like and how AppSec is implemented.
Awesome. And my name is Orion Cassetto. I'm VP of Product Marketing. I also have been in cybersecurity around 15 years. Also at a lot of AppSec companies, although I did a stint in security operations in the SIM market. Most of that time has been in either product management or product marketing roles and thinking about how to bring, products to market in a way that's innovative and can disrupt market spaces. So that's about us. Today's conversation I think should be fairly interesting because we're looking at balancing two very competing objectives. On one side, we have building an effective application security program, and that is in the face of kind of this ever-changing threat landscape and needing to do an awful lot and cover an awful lot of bases. And on the other side of things, we've got, we're kind of standing at the precipice of a potential economic downturn. A lot of organizations are not necessarily, they don't think the sky's falling, but they're looking at their budgets and they're looking at their projects and saying, okay, well, what could we do with less, or where could we trim the fat? So essentially what that really means for AppSec teams is, how do you do the same as you did last year or more than you needed to do last year, but with potentially the same budget or even less budget or less staff? And so, the confluence of those two items is a very interesting subject for us to explore. And so how we will go about that is first, we're going to talk about, what is the current situation on the AppSec landscape and, the threat landscape, and what do we need to tackle? What do we need in order to do a good job? Then we're going to do the same thing, but looking at it from an economic standpoint. So we'll talk through, budgets and, where are potential savings. And as we go through both the first and second subject, we're going to outline some requirements that we might need to satisfy to do a good job. Then when we get to the third section here, we're going to find a path forward. And what we mean by that is essentially looking at different ways to build AppSec programs and to spend money using the criteria from the first two sections and evaluating these different approaches. And then hopefully that will provide you some useful guidance for how you might, tackle this subject. And then we're going to open it up for Q&A. And as Cody said, so we've got the Q&A tab. So please feel free to use that and ask questions. We will answer as many as we have time for. With that, we're going to kick things off. So John, do you want to tell us a little bit about the AppSec landscape and challenges and how we face them?
Yeah, sure. Thanks, Orion. Yeah, so I guess it might help, if we explain kind of what we mean by this AppSec challenge, right? Um, the bottom line is that what we need to do is secure our applications, and just we're finding that the attacks and the breaches are all growing in prevalence, right? Our efforts to secure these applications just haven't entirely been successful. Some might even say they failed, right? What we're seeing is that attackers are specifically focusing on software supply chains now. They're trying to weaponize those software dependencies to infect the downstream applications, and in the runtime environments where those applications are running. The SolarWinds breach is a great example of this, right? The attackers infected a deliverable as part of the build pipeline, and that basically that malware which was infected was then delivered to the end users of SolarWinds. This style of attack is called a software supply chain attack, and Gartner expects that these attacks are going to triple over the next few years. Ultimately, what that means is that any organizations that are creating software, need to find ways to successfully secure this. And so going back to what Orion was saying earlier, it's not just a matter of being able to do what we've done in the past, but we're actually talking about having to do more than we've done in the past, regardless of what the kind of the budgetary climate is. And I guess that kind of begs the question, right? What problems does an effective AppSec program need to overcome in order to solve this problem? To answer that, it helps to consider kind of how is it the case that after, I don't know, 20 plus years of trying to secure these applications, how are we still struggling to secure them? And I think the short answer is that we're really chasing a moving target, right? Early security programs, if you can advance the slide. Early security programs really focused on securing the network infrastructure, the runtime environments. The idea was to protect the data that the attackers were after. And as we started to lock those down, attackers started to shift their focus, right? It was harder to get to that data directly. So instead of trying to reach the data directly through that infrastructure, they started targeting vulnerabilities in the applications that could access the runtime and the data. And so in order to prevent that, we started building AppSec tools to find those vulnerabilities in the apps. Obviously, if we can secure the apps, then the attackers won't have an opportunity to get into the runtime environment through those apps, right? That all makes sense in theory, but we did run into a few hiccups, right? I mean, for one thing, the AppSec tools produce so many findings that we can't possibly fix everything. I mean, it's not a matter of not being able to fix it. It's a matter of bandwidth, right? With the limited resources that we have available for development and for security teams, we have so many findings coming out of these tools that we just can't get to it all. And certainly not get to it all immediately, in the time frames that attackers are actually starting to exploit some of these vulnerabilities. And in fact, it's not just a matter of not being able to get to it. We don't even recognize which of those findings are real and which of those are things that we don't need to worry about, right? It's also a prioritization problem. And that's kind of how we got into this situation, right? We have AppSec challenges, we have budget challenges, but there's actually a bigger problem here. It's not just a matter of what the attackers are doing, but if you advance the slide, Orion, attackers aren't the only ones that are changing. We have kind of broader trends in the development industry, things like open source adoption, DevOps, the cloud. These kind of cultural shifts, if you will, are changing the software development landscape, and they're creating kind of new attack vectors in not just the cloud environments and the infrastructure where the apps are running and the apps themselves, but we also have new attack vectors that are in the development infrastructure. Not just the runtime infrastructure, but the development infrastructure and the pipelines that development happens through that are delivering that new software into production. And by and large, those are the attacks that we're starting to see today. Those software supply chain attacks are targeting that development infrastructure and the development pipelines. So now when we're talking about securing applications, it's not just that one target of securing the production runtime, right? We also have to secure the build pipelines, the artifacts that are being built by those pipelines, the dependencies that are used in that build process. And really, there's just a whole supply chain that attackers can use to gain access to those apps and that data that they can then use to breach organizations. And so there's really kind of a tricky, I mean, being able to solve this problem is really pretty tricky, because these tools, the tools that are used in the development process, they're typically selected, and they're purchased, and they're configured, and they're maintained all by engineering teams, and not by security teams, right? The engineering teams want to ensure that they're being productive, that they're being able to do what they need to do. And security is probably an afterthought to them in a lot of cases. Part of it just because that's not necessarily a primary goal, but also because they don't have the expertise that security teams do to understand what the security risks are and what they might need to be aware of in order to ensure that those tools are being used securely. And so in order to get those tools to be secured, security teams need to know what tools are being used, right? And a lot of times they don't. The selection, the configuration, all of those things are being done by the engineering teams, and the security teams don't even know exactly what's going on behind the scenes, or what tools have been chosen, what tools have been deployed, how they've been configured. So that kind of brings us to the first requirement for our AppSec solution, right? In order for the security teams to be able to secure these supply chain vulnerabilities, they're going to need visibility across all of the tools and activity that happen during the development process. But visibility into the supply chain isn't sufficient to solve this problem, right? I mean, we need to understand the risks that we face in addition to knowing what tools we're using. I'm sure it's not a surprise to the audience today that the complexity of this supply chain also means that it has a huge attack surface, right? In fact, that attack surface is so huge that no single tool is going to be able to secure everything. We have different phases throughout the development process, and each of those phases require different approaches. And honestly, there are whole classes of risk that aren't covered by existing tools. If you look at the slide here, each of the notes indicates a potential weakness that attackers could exploit. If an attacker could exploit even one of these weaknesses, then they gain a foothold into the development process. And with all of the improvements we've been making with DevOps and automated pipelines, once they get that foothold, those modern development pipelines actually make it easy for the attackers to pivot and move either upstream or downstream to other environments, to other tools. And so that brings us to our second requirement, right? To protect against this wide variety of risks in the software supply chain, we're going to need a collection of tools that broadly cover all of this huge attack surface, because simply focusing on specific risks isn't sufficient. If attackers can find a single weakness, they can get in and then they can pivot and move anywhere else throughout the environment. So we already have some of these tools, right? We have tools like SAST and SCA. There's container security and runtime security. These tools are looking for very specific risks, and their visibility is limited just to what they're inspecting, right? I mean, runtime security is looking at the runtime to find vulnerabilities. And SAST is looking for vulnerabilities in the code, but it doesn't know how that code is actually being used. I mean, it knows what's in the code, but it doesn't know what's going on outside the code, right? What data is that code being exposed to when it's actually running? Is that code actually running in production? So all of these tools are effectively operating in a silo. They don't know anything outside of what their area of expertise is. In the case of SAST, that's the code. Runtime environment is just, or runtime security is just looking at the runtime environment. And all of our AppSec programs, our existing AppSec programs, are built on these tools. And I think we can say that it's safe to say that existing AppSec programs have demonstrated that using a bunch of disjoint tools leads to overwhelming noise and suboptimal security outcomes. There's just too much information for security teams to deal with. And so all of these tools are important, but we really struggle to use them. If you can advance the slide, Orion. Because we lack the context to understand that bigger picture, right? I mean, how do the findings relate to each other? How do they relate to the broader development process? Does code come from trusted developers? Are vulnerabilities that are found through SAST or SCA actually deployed into production environments? And if so, which ones? So we could say that that's our third requirement, right? We have tool findings, but we need to correlate those with their context in the SDLC. We need to be able to build an understanding of kind of cause and effect across the application lifecycle. That correlation is important for improving the security outcomes, right? The real world risks are often associated with multiple risk markers at different points in time. It's not just a single tool telling you that there's a potential problem. You take that information and you can kind of correlate it and use it to augment your understanding of exactly what's happening. Just as an example, if we have a hard-coded secret in source code, that's a potential risk. Obviously, we want to get rid of it, but there may be more important issues that we need to deal with first. If we know that secret is actually used in runtime, and we know that the code has been exposed to untrusted users through a code leak, then we know that that particular secret finding is an urgent risk. We need to deal with it immediately because it's been exposed to attackers. And similarly, if we check artifact signatures during deployment, that's great to know that we're deploying the right artifact, but how do we know that that signature wasn't forged, or that the signed code wasn't tampered with earlier in the development process, like it was with SolarWinds, right? The correlation information enables us to validate the history of that artifact back through the container that's being used, the build that built the container, the commits that went into that build, and ultimately which developers created the code that was ultimately deployed into the runtime. So our fourth requirement is that we need to be able to gain deep insights into risks that manifest over multiple related data points, not just single potential findings. So putting all of that together, right, if we want to address the AppSec challenge, then we really need tools that are going to satisfy four requirements. First, they need to provide visibility across the entire software supply chain. They need to provide good coverage over all of the all of the risks in that vast attack surface of the software supply chain. The tools are going to need to correlate that information so we understand what's happening where, as well as its context in the broader SDLC. And the tools are going to need to provide deep insights into risks and attack paths that involve observations at multiple points in the SDLC. So as we get into the later parts of the of this presentation, we're going to evaluate several different approaches based on how well they satisfy these requirements and the budget that they're going to require as well.
Awesome. Thank you, John. All right, so we're going to shift gears a little bit, and we're going to go from addressing the AppSec landscape to addressing the budgetary challenge. So in this section, we're going to do similar things to what John just did, but we'll be looking at it from a more financial and economic and resource point of view. The place to start here, though, is by understanding your organization and its unique needs and its current and needed resources. And you can get to this point in a number of ways, but one of the easy ways is to kind of look at various facets of your business and organization and understand where you stand. The first one is threats. Now, not all organizations have the same risk or threat profile. Some organizations, based on the nature, type of business, who they do business with, whether they're federal government or private enterprise, etc., are more likely to face certain kinds of threats than other types of threats. And if you just made a big broad spectrum and said on one end is persistent nation state types of attacks, and on the other end you said, okay, well, the attackers on this side are kind of spray and pray, opportunistic, looking to build and use exploits that are repeatable amongst a number of targets. You kind of get this spectrum. And so depending on your type of business and resources and assets and you may face different types of threats along this threshold. And so spending a little bit of time to think deeply, are you actually a nation state target, or are you more of a kind of mass exploit type of a target? That can help you to align resources accordingly, because honestly, we'd all love to have an unlimited budget, but frankly, we don't. Second is architecture. So what types of applications are you using? How are they designed? Where are your resources? Are you on-prem? Are you in the cloud? Do you use microservices, etc.? All of these types of architectural decisions that you've made also have implications when it comes to your security spend and the products that you need to buy. Maintenance is another key aspect. So here we're talking about the ability to do updates on your tooling and tuning, onboarding new tools and apps, training your team to use them, wrapping processes around them, M&A and business units that you buy and whatever they have, and your ability to maintain that. And so this is a very real cost, and you need to be thinking about this when you're making kind of your tooling and selection decisions. Staffing is another one. Are you able to keep up with the output of all of these tools? Is it overwhelming? Do you have duplication? Is the false positives, at a spot that it's creating undue burden on your team? What does the actual workflow and process look like to get through this backlog of things that you need to deal with? Likewise, development resources are very important. They're important in a couple of ways in the AppSec world. First and foremost, it's about implementing and customizing and standing up tools. But it's also important when it comes to fixing some of the problems, because some of the problems in the AppSec world come down to code, and the people who are going to fix those specific vulnerabilities are developers. So do you have the capacity to handle the output from the tools that you have? Are the tools making your lives easier or harder? And then finally is capital, and this comes in a couple of ways, both people and money specifically. Okay, so from there, we're going to look for ways that we can start to optimize. So where are our potential cost savings? And the first one is essentially comes down to licensing costs, and it comes down to alignment with your existing, aligning your tooling and what you're spending on those toolings against the threat profile that you're likely to face. And there's this idea of underserving or overserving, and it's essentially, do you have more or less of what you need to do the job that you're trying to do? Now, essentially, when you under or overserve, if you have more of something than you need or less of something than you need, you often end up with a misallocation of resources. And this can come in a couple of formats. I mean, one way is that the cost of a particular tool might be more than the benefit that you're getting out of it. That would be, being underserved, right? On the other side, you may pay a premium for capabilities that you don't need, or you may use or pay for things, be paying for things that you're not getting. But ultimately, any amount of kind of misalignment between your needs and your licensing costs puts you in a situation where you're essentially misspending your budget, and that may cost your ability to take on other projects that may be critical to your security program. So as we start to move forward, we need to pay very critical attention to this and say, like, well, are our budgetary or are our licensing costs aligned with our risk profile? Essentially, that's the bottom line. So when we look at some of the approaches in the back half of this presentation, this is going to be one of our requirements that we're going to want to maximize. Some examples of this in common tools that are in the AppSec world. So SAST is a very common example. Here, oftentimes people have more than they need. So SAST's job is to find vulnerabilities in custom code. So the first thing to know that, SAST has been around since, the early 2000s, and essentially its job is to find vulnerabilities in custom code. Well, at that time, custom code made up a huge amount of your code base. Nowadays, custom code is a much smaller amount of code base, and instead people are including, open source frameworks and libraries and components that make up the rest of the code base. So it went from being virtually 100% of your code base to, 10 to 20%. So by nature, the value that tool is providing has kind of diminished over time. But there's some other reasons that people often are kind of overspending on SAST. One of them comes down to that question of where on the spectrum of nation state to opportunistic kind of, rinse and repeat attacker, where do you fall from a risk threshold standpoint? Because, creating an exploit that is custom to your custom code in your application, from an attacker standpoint, that is a very expensive way to frankly, for them to do business, for them to attack things, because they need to do a lot of reconnaissance. The exploit that they develop is custom to your application. It can't be used for anyone else. And so, they have to invest an awful lot to do that attack. On the other side of things, though, if they were to, go after an open source library, they can find vulnerabilities and understand how to make an exploit based on CVEs, and then just find out, one exploit might be useful for a ton of people. And so, if you find yourself in the camp that is all about, hey, I'm facing nation state threats, then, the value of SAST goes up. If that is not the threat profile that you face, then the value, proportionally is a little bit less. Ultimately, for many organizations, SAST's value comes in a couple of things. It comes in finding the OWASP top 10 types of threats and, injection vulnerabilities and things. It's like basic injection problems and developer neglect and mistake, right? And that has absolute value because we want the low-hanging fruit off the table. But if you really thought about like what is firing and what is SAST finding, the 80-20 rule applies perfectly. So, basically 80% of what's found is the same 20% of the rule set, and it tends to be the OWASP top 10 types of stuff. You absolutely need to handle that. Another big area of value is compliance. So if you think about compliance regulations and frameworks like PCI DSS, just to name one, it requires the use of SAST. And so you really do actually need to check that box because you can't, find yourself out of compliance, especially if you're in specific industries. So the whole point of this is that for many organizations, do you need the best SAST on the planet? Maybe not. If you face nation state actors, perhaps. For everybody else, the value is in finding basic injection vulnerabilities, developer neglect and compliance. And so does that need to consume half of your AppSec budget or a huge portion of it? Maybe not. So that's one example. Another example is SCA. So this is another super common tool. And, I said earlier, so the way that code bases are made up has changed from being largely custom code to largely, kind of open source libraries. SCA is going to help to find vulnerabilities in those open source libraries. So it inherently definitely has value. The problem is that software composition analysis has basically been marketed as a way to, manage the entire risk of dealing with vulnerable dependencies. And often, sometimes vendors will even go so far as to say this solves software supply chain security. Now, clearly that's not the case, but if you just relegated it to the world of, vulnerable dependencies, it's still not quite doing the whole job because essentially SCA is looking at, open source libraries and code dependencies, but there are a number of types of dependencies. So, if we look at it this way, SCA is good for code dependencies and open source frameworks or open source libraries. There's a ton of types of dependencies that have the same risk to your organization that pop up elsewhere in your pipeline that SCA is not looking at. Things like dev tools. So, TeamCity is an SCM. That's a developer tool, right? And that ended up being part of the SolarWinds attack. Just 2 weeks ago, GitLab had a security advisory. They had a vulnerable version of GitLab. And then there's also, above and beyond those tools, there's plugins to those tools. So in July, we had a security advisory where there were 34 vulnerabilities or vulnerable plugins to Jenkins, right? And that's, again, a dev tool. Moving a little further into your pipeline, there are other dependencies that pop up. There's, build modules, so things like GitHub Actions and GitLab Runners. Those are often created by other organizations. So you might, get it out of a marketplace and, it's written by Red Hat or CodeQL or somebody. So that's something you're using to make your software that, is not in your control, but could be vulnerable. And those are written just like normal software, meaning that they often have open source libraries that they use. And, they may bring in a vulnerable package that ends up again in your build pipeline. So another type of dependency. And then even if you use infrastructure as code, you may end up running a script at some point that pulls in a package that could be vulnerable. And so, even SCA, if you just look at that one tool, which is arguably definitely valuable, it's not really doing the full job that the full bill of goods that it's being, promoted to do. And so, does that mean that you should spend all of your money on it? Probably not. You need to balance that with the risk threshold, because really over here on the left, you need to deal with all of this stuff. And there's another class of tools that does this. It's called pipeline composition analysis, but that's another subject. The point of that ramble, though, is that kind of over and underserving and misalignment with tools puts you in a situation where you may spend the lion's share of your budget and have only, a small percentage of the total attack surface dealt with. Like, you've got SAST and SCA over here dealing with 2 of the attack vectors. But what about the other 13 or 14 that are on this slide, right? Those are still on the table for attackers. You need money for that as well. Okay. The second potential area for savings comes down to operational efficiencies. A good analogy could be made between kind of VMs and containers here, but at the risk of getting into the technical weeds, I'll keep it to the material we've got here, which is essentially like, look, when you buy an application security product, it comes with a lot of fit and finish and a lot of enterprise features that are required to make it easy for your team to use. And every vendor has kind of the same stack of that stuff. It's things like, configuration, it's integrations into your environment, it's, management and administration, and, remediation workflows and reporting and compliance dashboards and whatever it may be, right? But the problem is that vendor A is building that, vendor B is building that, vendor C is building that, and they're all investing their engineering resources to get the fit and finish that you need to make it useful for you. But because they had to, invest their time and effort and money on that, then they pass that cost along to you. So the first thing is that increases license costs. The second thing is that from a workflow or operational efficiency standpoint, your team is having to, basically, have swivel chair syndrome and use, this interface for SAST and this interface for SCA and this interface for their WAF. And that is essentially less operationally efficient than doing it on a single platform. Here, you have one set of configuration, one set of integration, et cetera, all the way up through reporting and management and compliance. And that is just a more streamlined workflow. Simpler, faster workflows, less complexity. And, when it comes down to licensing costs, again, the organization that is offering this is not investing in this in 5 versions of each of these modules, just one. And so that means that from a licensing cost standpoint, that can also are savings that can be passed forward to you. So the requirement here is essentially, when we're evaluating approaches, is to reduce operational redundancy and complexity. We want our workers and our everything as streamlined as possible, our tool selection as non-redundant as possible. The third major area that we can look for savings comes down to development costs. So developers have a very real role in AppSec. They help to implement and customize tools and get them stood up in your environment. And more tools means more of that, more implementation, more customization. But also, essentially in the AppSec world, a lot of the work to be done may involve developer workflows. So, looking at scanning things that they're developing, looking for vulnerabilities or security issues, providing information to developers so they can fix it. And essentially, more products inserted into what are otherwise very automated and autonomous workflows means more potential slowdowns and bottlenecks and blockage that hinder your developers, kind of ability to be efficient. And so, the more tools you have, the more risk you have there. Also, as those tools start to find issues and vulnerabilities, somebody has to go research them and understand, is this a real thing? What needs to be done? Then they have to go implement a fix. And any false positives along the way are wasting time. And so essentially, more products can sometimes make more work to be done. And so ultimately, you need to be thinking to yourself, well, how can I implement tools that don't waste my development resources or minimize the amount of development resources that I need to do my job, so that I can be doing other more productive things with my developers. So that is our third criteria. And if we zoom out and we say, all right, well, what are the three things that we're going to be looking at as we look at our different approaches? It's reducing licensing costs, it's reducing operational costs and redundancy, and it is reducing development costs. All right, so I'm going to hand it back over to John. Now we're going to bring these together. We're going to look at different approaches, and we'll rate them given kind of the rubric that we've just built. John, over to you.
Great, thanks, Ryan. So we've kind of outlined, what are the AppSec and the budget requirements that we need to satisfy. This section kind of focuses on how do we find a path forward to implement those requirements and make sure that we're, kind of reaching that ultimate goal of doing more with less. The scenarios are really going to focus on kind of how well they meet the AppSec and budget requirements. In order to do that, we're going to use kind of this type of a chart, right? For each of the scenarios, we're going to evaluate their ability to satisfy all four of the AppSec requirements that I went through earlier, right? The coverage of all the risks that are present in the SDLC, visibility into the activity across that SDLC, correlating that information between risks and activity to really understand that important context, and then being able to provide insight into those complex risks that involve multiple risk markers. And on the budget side, we're going to look at the three budget requirements that Orion just went through, right? The cost to acquire the tool licenses, the direct and indirect cost on your team to use and maintain the solution, and the cost on your development team or possibly for contractors, right? To select and assemble those tools, to glue them into your processes, and so forth. An ideal score is going to look like this chart that we see here with the basically the entire chart has been filled in with that blue area. We've organized the scoring so that the more desirable scores are closer to the outer edge and less desirable scores are toward the center of the chart. And so for our first scenario, we're going to look at a scenario that leverages a collection of established point tools. As an example, right? Maybe we have the capabilities of your SCM tool that we're going to use for SCM and for SCA and for secrets management. We'll have a separate SAS tool for the various languages that you use to make sure that you can scan all of that code. And we'll probably have a few other tools that cover infrastructure as code risk, runtime risk, and maybe container scanning. This approach is going to give you pretty good coverage over the security risks, especially in the runtime and the application code. And it also gives you pretty good visibility across the SDLC because you're looking for a variety of different types of risks. But all those tools are going to be expensive to license because we're talking about, a collection of established tools. And the operational costs are going to be pretty high because we're dealing with a number of different tools that need to be integrated and all of that. And we're also going to have to deal with a lot of noise coming from all of these different tools and potentially duplicate findings. But probably the biggest problem is that this collection of point tools isn't really covering much of the supply chain risk. It focuses on the application, it focuses on the runtime, but the development process itself isn't really being addressed, and we don't really have any insight into what's happening during the development process, so we can't really get that correlation between the risks and the activity. And as a result, we're not going to be able to do much to develop those deep insights that require multiple risk markers. So the high cost of the solution is really going to make it hard to free up budget to acquire new tools that are going to cover those gaps as well. So in an effort to kind of avoid those high costs of having all of these kind of established point tools, what if we were to focus on open source tooling? We could leverage tools like Cloud Custodian and SemGrep and Trivian, Dependabot, and use those to find risks in our cloud infrastructure, application code, containers, and dependencies. There are actually a lot of open source tools that are available, and they cover most of the major risks that we are going to need to deal with. And doing so is certainly going to lower the licensing cost because it's open source, it's free tooling, right? But really, this is taking on a really big project that your team is going to have to deal with. The operational costs are going to be much higher, and you're going to need access to, or you're going to need the ability to pay for contractors that provide the development resources to build and integrate and kind of glue these pieces together, right? With a commercial solution, you could rely on a vendor to build that tool and to handle a lot of those integrations and the development pieces that are necessary to stand these tools up in your environment. But in this case, if you're building those things from open source, you're going to need to do that. You need to do the tool selection. You need to build the integrations. You need to build all of that glue code and the processes. And even once all of that's put together, you need to keep it all running, right? Because each of those tools is going to be updated in the future, hopefully. And as those updates come out, some of those could be security fixes. They could be other types of issues that you need to make sure are getting incorporated into this open source platform that you've put together. So ultimately, you're becoming the vendor here, and you're going to need to deal with selecting the right tools and ensuring that you're getting good quality results out of them. And at the end of the day, you haven't really reduced the budget very much. You've just kind of shifted the costs from licensing over to operations. So looking at kind of a third scenario, right? We saw earlier that using a collection of point products provides pretty good coverage. It is a bit expensive, and it doesn't really address kind of the correlation or the insight requirements. But what if we leverage some sort of a consolidation platform that can kind of pull all of those tools together and all the results together, right? We can maybe free up some of our budget by streamlining on the operational side and using the platform to correlate the results and maybe standardize some of the workflows to improve that operational efficiency. If we call this kind of a single pane of glass, right, we can get the same benefits as we had with that collection of point products. And we can also reduce the operational costs by simplifying the integrations and the workflows. But one of the problems is we haven't really reduced the licensing costs because we're still using that same collection of point tools. And we've actually increased the development and the integration costs because we need to build a more customized platform. We still need to do all of the development and integration that we had with the collection of point tools. And now we have this kind of single pane of glass platform that we need to integrate into our process, and we need to integrate those other tools into that platform, right? One of the benefits is that we are improving the correlation and the insight, right? These tools are able to correlate the findings that are coming out of the security tools and kind of integrate that into the correlation platform, that single pane of glass that puts it all together. But we're really lacking that contextual SDLC data, right? We don't understand how the tools are configured. We don't understand who's using them and what their permissions are. And we don't really have much insight into how those artifacts are moving through the SDLC. So we've kind of looked at we're able to correlate the dots, but we're not really able to understand, well, we don't have visibility into all the dots that we necessarily need. So we're still a little bit short, I think, of the goal that we want here. So if we move on to the next one, right, where our single pane of glass selection scenario is kind of collecting those dots from the AppSec tools, what we really need is a solution that understands all of the dots. So it's not just collecting the output of security tools, but it's also looking at what's happening throughout the SDLC, even things that aren't necessarily security related. And then we need a solution that's going to connect all of those dots together, something that marries the findings of the AppSec tools with the SDLC context, so that we can improve those security outcomes. We can call that kind of next, or that next scenario, a next-gen software supply chain security platform. And what we're really trying to do there is to understand the relationships. We can kind of leverage a graph database to consolidate as much of that information together into a single platform, not just the security findings, but all of that SDLC activity as well. And it'll correlate that AppSec data with the SDLC context. And, it can be used to establish those consistent integrations and workflows. And because it understands the relationships between the events and the context, it can really provide those deep insights that are based on trends and multiple points of data across the SDLC by coordinating all of those tools together. And I guess if we move one forward, we're going to get that. We're going to be able to produce more accurate results. We can improve that accuracy because we understand the context better. We can better prioritize things because we understand the upstream and downstream relations to the specific AppSec findings that are coming out of the tools. And we'll be able to ultimately lead to faster remediation because we have all the information that we need in one place to understand and fix things quickly. So as a result, this kind of next-gen AppSec or next-gen software supply chain security solution really has great coverage of our AppSec needs. Not only the coverage and the visibility, but we also have great coverage of correlation and the insights. And the platform is going to eliminate the need for lots of expensive and redundant functionality in the various point tools, like Orion was talking earlier about the operational efficiency. And if we think about how these pieces fit together, right, the correlation and the context is also going to greatly reduce the maintenance and the operational overhead because we're delivering those more accurate findings, more actionable insights. And ultimately, we're really breaking down those silos that we saw in the earlier slides between the various AppSec tools. And by breaking down those silos, we understand the context, and we're really able to do a better job with the information that we're getting out of the tools. So if we go, if we kind of wrap all of this up, right? I mean, ultimately we can't tell you which scenario is going to best meet your needs because you understand what your risk profile looks like. You understand what kinds of threats you're facing, and you're the only one who really understands what your budget and other internal constraints might be for your AppSec programs. But hopefully some of these charts are going to help you kind of compare and decide how the different scenarios might help you address those needs that you're facing. Kind of based on the ideal profile that we discussed earlier with the various requirements that we laid out. Looking for strong security capabilities and low overall costs. A next-gen software supply chain security platform really seems to be a great choice, right? It provides that combination of great coverage, visibility across the SDLC. It helps correlate the context into that picture and provide those full lifecycle insights. And it's really a powerful way to help improve the security outcomes while reducing costs.
Awesome. Thank you, John. So, kind of in a session recap, so we're almost to Q&A. We've talked a lot about, the needs of modern AppSec programs, various ways that one can, essentially meet much budgetary requirements. We've walked through a model that kind of evaluated things. And then we gave you, several examples and kind of rated them using that rubric. So hopefully that is helpful. One last slide before we go into Q&A, just a little bit about SciCode if you're curious. We are a software supply chain security platform. That you probably figured that out. We offer 8 different AppSec tools that essentially go to the same goal of plugging all of those different attack vectors across the SDLC that John showed us. They're largely in 2 main groups. The first group is those that find vulnerabilities across the entire SDLC. So you've got a SaaS tool to find them in custom code, a SCA tool to find them in your dependencies and open source libraries, container scanning to look for them there, an IAC scanning tool to find misconfigurations that would turn into vulnerabilities in your cloud infrastructure. And then on the other side of things, there's a whole class of tools that the kind of commonality on the pipeline hardening side is basically preventing attackers from getting into your SDLC and preventing breaches. And that really comes down to pipeline security and governance. So understanding the configurations of the tools of the pipelines and the security controls you have in place to make sure that they're hardened. Code tampering, so understanding how code is moving through your pipeline and how it's progressing through each of the different handoffs from stage to stage, and making sure that it maintains integrity along the way. Hard-coded secret scanning is looking for hard-coded secrets throughout your entire SDLC, not just in your code. And code leakage is looking for signs of your proprietary code out in the wild on public code sharing sites. All of this is sitting on top of that graph database type of backend that can correlate data with not only the SDLC, but across all of these different data points. That's our last slide. So what we'll do is we'll go ahead and open it up for Q&A. So if you have questions, feel free to put them into the Q&A panel, which is there on the right side of the webinar console. And we'll go ahead and start answering some of them. So we've got some coming in. Okay, so one says you mentioned pipeline composition analysis. What is that? Essentially, pipeline composition analysis is the same idea as software composition analysis. It's just looking at a broader scale. So it's looking at not just code dependencies, not just open source libraries, but it's looking for any dependencies. Things that you are dependent on that other people create that could be vulnerable. So that's tooling, plugins, build modules, and more. It also has a couple of other unique kind of cool benefits. Instead of when it comes to finding the vulnerabilities, it can tell you the location, but not just in the code, but because it's looking at the whole pipeline, where did it get deployed? So like if you had to answer a question like, do you have Log4j? It could tell you yes or no, do you have it? But did it get deployed anywhere, and does it still exist out in the wild somewhere? It also has some other cool benefits in terms of prioritization, like, if you can tell, is a specific vulnerability exploitable from the outside world based on what's running in production. But, long story short, the idea of SCA, but expand it out to your entire pipeline. Okay, next tool, next question, I guess, is for you, John. Why doesn't a collection of best of class tools or single pane of glass using those tools, why doesn't it score higher on insight or correlation? So I guess, backing us up for half of a sec. So the question is, over here on the insight and the correlation, why didn't the left 2 panes, why didn't they get further to the outside?
Yeah, sure. So, I think for the most part, it's about SDLC context, right? The single pane of glass is really taking the output of various AppSec tools and correlating that information together to try to, well, it can help you do things like reduce the duplication that's coming out of different AppSec tools. But the piece that's really missing is that SDLC context, the information that doesn't come from AppSec tools, that isn't, it may not even be considered, a security risk in itself. Things like who are your developers? Where does code come from? How is code being processed in the development process? And by understanding those things, even if it's just understanding what normal secure operations look like, taking that information and marrying it with what we know about AppSec risks that are being found by the various tools like SAST and SCA is really where we're able to do a lot more with it. So I would say that kind of that single pane of glass, the collection of best of class AppSec tools, is really just missing kind of that extra dimension of what's happening, and as a result, they're not able to really provide that correlation between security risks and normal development process, and they're not able to develop the insights because they don't have enough information to really understand some of the activity that may represent a risk that the siloed AppSec tools aren't going to be able to identify.
Yeah, and if I could tag onto that, I feel like it's if you don't understand, putting results into one place is all well and fine, but if you don't understand how they relate to each other and relate to your development environment and whatnot, you're never going to be able to track things across the entire SDLC, and you just can't get out of those little data silos. You might have a more efficient workflow, but it's not getting you any further in terms of like your ultimate AppSec needs.
Yep.
Okay, so next one's pretty fun. Can't I just put all this data into my SIM and get to the same place as a next-gen platform? So I spent half a decade in SIM, so I'll take a stab at this, and then John, keep me honest. Feel free to add anything you want. But I think the answer to that is no. So a lot of the information that you need in order to have the context that we're talking about here, some of it would generate a log that could go into a SIM. Like this thing happened in this tool, and there's a change of these settings. Some of it is about like the environmental settings of your organization or of your SDLC. What security controls do you have in place? What permissions do these people have? And so first off, you couldn't even get all of the data needed to do this into a SIM via logs. So if you're relying on logs, that's not going to get you there. Secondly, though, it's, basically what we're talking about here is building a system that's capable of understanding how, both environmental information and security information across your SDLC relate to each other, and then building, a whole bunch of, kind of rules and law and learning and thought on top of that's helping to push forward your application security program. And so, like, in theory, you could do some of that in a SIM, but it would be very, very expensive, and you would basically turning yourself into a vendor and building a ton of products on top of that. That would be a very, very expensive proposition. There's just no way that it would match the idea of doing more for less. It would be doing less for more. So potentially possible, but I wouldn't recommend it. I don't know, John, if you had anything to add to that.
Yeah, no, I ultimately, yeah. I mean, like you said, right? It's almost like you're becoming an AppSec vendor if you're going to do that. There's that big technical challenge is just getting the information into the SIM in the first place, and then there aren't any existing tools for getting the information out of the SIM and producing those insights that are going to be useful. You're going to have to build all of that yourself as well.
Yep. So we've got just 2 more minutes before I think like a kind of virtual hook is going to come and pull us off the stage. But one question that we've still got is which programming languages do you support? John, I think that's probably better for you.
Okay. Yeah. I mean, I think. Well, I guess there are kind of 2 parts to this, right? There's the supply chain risk perspective. In that sense, looking at the pipelines and understanding what's happening, and looking at the various development tools and their configuration, all of that stuff is language agnostic. We don't really care what language you're using for your application for that sense. We can monitor repositories and pipelines and activity and all of that stuff to understand the development process. And we can also help to secure the supply chain from that perspective without understanding the programming language, simply by looking at the activity and being able to detect anomalous activity, things like that. Looking for tampering. It doesn't really matter what the language is. We just are looking at what's happening. So that's the kind of supply chain security side of things. The tampering and secrets and whatnot. But we do have some language-specific parts, right? I mean, we have a SAST engine, we have SCA, we have infrastructure as code scanning, and in those senses, kind of, well, I can't really list all of the languages that we have. They're just too many. But certainly for tools like SAST and SCA, we support all of the modern major languages, things like Java and C# and Python, JavaScript, PHP. If somebody needs like complete details, they can go to our website. We have a list there. Or if you have a specific question, obviously they can send a question and or send us an email, and we can answer something a little more specific if that's needed. From an IAC perspective, the infrastructure as code, we support Kubernetes, CloudFormation templates, Terraform, and I think Azure Resource Manager are the 4 major ones right now. But at the end of the day, we're really adding new support all the time. So it's quite possible that we support something that I'm just not aware of yet. So if you're watching this from a recording, for example, it's very likely that support has changed. So feel free to reach out to us if you need something that isn't listed and you just want to verify that we support it.
Cool. Cody, John, thank you. Cody, back over to you.
Awesome. Well, John and Orion, thank you both for joining us today. Both filled out the hour to the tippy top, so I hope our audience was able to pull quite a bit from this presentation. So thank you both. I would love to remind our audience that this session was recorded. So following this program, you should receive an email with a link to access that recording on demand, or you can find the recording living on the Security Boulevard website at securityboulevard.com/webinars, and just be sure to look in the on-demand section. So we do still have 4 $25 Amazon gift cards to give out. Our first winner is Rickwan B. Our second winner is Gang Y. Our third winner is Curtis B. And our fourth and final winner is Kenneth F. So to our 4 winners, congratulations. Please keep an eye on your email inbox to claim that gift card. But if you do not happen to see that email, do check your spam folder. I would love to thank SciCode for sponsoring today's program. Couldn't have made today happen without the sponsorship and support of SciCode. John, Orion, thank you both. And to our audience, thank you for joining us today. We do just ask for one extra moment of your time for a brief survey that will pop up as soon as we close out, but otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Have a great rest of your day.